Okay, everyone, it looks like we're just about our forum here. I'd like to introduce myself. I'm Wayne Griffenberg. I'm a senior technical specialist on the Fusion 360 team here at Autodesk. Today, we're going to focus in on Autodesk Fusion 360. This webinar is for those of you who are new to 3-axis CAM. And hopefully that's our goal, is to help you guys get up to cutting chips in no time. I'm joined by Jason Lichtman, who is also on our Fusion 360 team. He'll be manning the chat. So if you guys have any questions, please feel free to ask along the way of this webinar. And we'll have some time towards the end that we can answer questions as well. All right, so we have a lot to cover, so we're going to jump right into it. So I want to give a brief introduction of myself and an introduction of Autodesk as well. Today we're focusing in on why would you consider CAM software. So if you're like a mechanical designer, or if you're a mechanical engineer making prototypes for your company, and if maybe you're a new machinist who's just joining a new shop and new to CNC machining, this is really for you to think about ways that you're probably considering ways to get up to speed, to program quicker, to be more efficient and more consistent, and maybe even have a cost-effective way to get your programming done versus programming at the control. So we're focusing in on a lot of those aspects. And also, why choose Fusion 360? Well, it's easy to use and easy to learn, and we have an integrated, streamlined workflow to go from CAM, should I say CAD to CAM, to putting your toolpaths on, access to a lot of the post-processors that run most machines today. They're all free. There's free training. You have access to experts online and YouTube videos. And as your company grows, how you can also have Fusion 360 grow with you. You can add seats and extend your capabilities with using the tool. So we're going to focus in on there. And at the end, we're going to summarize, and we'll have ways that you can contact our team throughout the world to get more information on Fusion 360 and how you can get up on your subscription. So again, please feel free to ask questions along the way. Jason's manning the Q&A section of our webinar, and so we'll be able to get those answers for you. So brief intro on myself. I'm Wayne, nice to meet you. I've been in the industry for over almost 30 years. So I got my degree at Penn State in MET, Mechanical Engineering Technology. I have over 20 years experience in the medical product design, working with infant incubators and warmers, and as well as knee implants, hips and knees, and some experience in the industry supporting tools like CAD and CAM in my career. It was exciting to learn a lot about those different capabilities in the medical world, and so I'm happy to be able to share that knowledge with our august body today. So a little bit of a history and background on AutoCAD or Autodesk. Let me make a quick change here. Oh, sorry about that. I'm going to share, and I want to make sure I optimize our video so that you guys can see this video. So I have a little bit of a video to play, and a little bit of background on Autodesk itself, right? So Autodesk is a software company. Our mission is to enable innovators, much like yourself, to be able to design and manufacture better products, right? So to transform the way you make those products, and also to help you experience your ideas before they become a reality. Autodesk focuses on 3 main sectors of the industry. One is media and entertainment, where we provide products that are used for automation or animation and rendering, like 3ds Max and Maya, which are used to make major motion pictures like the Avengers or the Spider-Man series, or professional video games like Halo or Detroit Become Human. Which is a pretty awesome game, by the way. And another one is architectural, engineering, and construction, where we connect large building designs with construction projects using tools like Autodesk and Revit, AutoCAD and Revit. And this is all combined in an interactive a collaborative environment, which is BIM 360. Finally, we have design and manufacturing, where we have a collection of products and applications for for product design, which is on our CAD side, for simulation and analysis, which is our CAE side, and our integrated CAM on our manufacturing side. So all of these capabilities are all what make up Fusion 360 as that one design and make platform that combines it all. So today's focus is on specifically looking at how Fusion 360 would be a good choice to consider for your CAD to CAM workflow. So with that, I'm gonna switch again back so I can optimize so you guys can see my screen a little bit better. So let's focus in on what are those tools look like, or why would I want to consider some CAM software in the industry? Oops, there we go. So let's look into some of those different aspects. So first, if you're thinking about if you're in a shop and maybe you receive a lot of different parts from customers, they could be in different file types: SolidWorks, Solid Edge, Pro E, CATIA, and even your standard STEP and IGES files. Well, we have over 50 different translators where you can bring those files directly into the interface. If you have to make some changes, you might not be a mechanical engineer or designer, but you still might need to make some changes to make those parts makeable. We have an integrated way to do that in our CAD side. When it comes to CAM, that integration, you could just simply switch over to another workspace, add those toolpaths that you need to be able to select the post processor specifically for your machine to post out. Now, these are things that you might want to consider when you're looking for a CAD CAM software. A good, affordable way, like cost-effective way that you can apply those different tools instead of, again, programming, getting a print or a PDF and programming at the control. Right, so think about those different aspects as you start to look into CAD CAM software. One of the major things I like, there's a blog that was written by Marty Deans. She's a programmer. She's actually a product manager here at Autodesk. Wrote a really good blog on the power of having good CAD. I think she even coined the phrase of having better CAD for CAM. So one of the most fundamental parts of getting a good program, a good toolpath and good G-code to your machine is starting with good geometry, right? So if you're working with a 3D part or you're uploading a 3D part from a customer or even have 2D geometry, the better that geometry is, the better your end result will be. So it's a good focus to find a tool that's going to have a lot of that CAM interface. Again, even if you're not going to be designing a whole bunch of parts, it's definitely a good aspect to look for, especially if you have to make changes to customer parts. So if you have the capability of doing, of course, sketching and parametric design, maybe some direct editing, or maybe you have some mesh files that the customer sends over to you, like object files or STLs, you could bring those into the interface. Can you work with those? If you're working with assemblies, to bring in vices and making fixed jaws or even soft jaws for those different vices, you want to have a powerful CAD interface to be able to work with. Same thing if you're working in the CAM workflow, like you want to focus on a tool that's going to have a very robust tool, like, capabilities and toolpaths for 2.5 axis, 3-axis milling. If you do positional for, 3+1, 3+2. If you're doing multi-axis simultaneous, I mean, you have to take these things in consideration and think about the tool that you're going to use for that integration of CAD and CAM. If you're doing turning, mill turn, keep those in mind too. I talk to a lot of customers who often say, I do a lot of 3-axis milling, but the turning we usually do at the control. It's pretty easy, which is perfectly okay. But if you had a tool that had it built in and the same exact streamlined workflow, why not use it? Why not take advantage of that capability if it's in your CAM system? Another aspect to think about too is extending your capability, right? So we mentioned earlier, if you expand your shop, if you have better workflow, maybe over time, you might find or get parts that have maybe more tighter tolerances, or maybe you have to do a little bit more multi-axis work, or even probing to check that geometry or surface geometry where you can extend your capability. So you want to look for a CAM software that is expendable or extensive, or you want to be able to expand out and use some tools where we have Power Mill and Feature Cam and Part Maker and Power Inspect here at Autodesk. And we're bringing those tools as capabilities that you can extend your possibility and extend your capability of your shop. Where if you're looking for automation like feature cam or feature-based machining, you can extend that. You can just turn it on when you need it and turn it off when you don't. Same thing with multi-axis machining. We have some capability for doing more surface finishing, like steep and shallow, of getting like more mold parts and more accuracy at the end. And you can also automate and probe those different surfaces to check and make sure that the surface finishes within tolerance. Tools like nesting, another extension. So if you have a lot of parts that you make for production, want to lay them out, we have the capability where you can extend there as well. So I like to also kind of give some of those benefits. A lot much quicker throughput by extending out. You can get your parts off the machine with higher quality, being able to do this affordably. So you don't have to have one of those high-end CAM systems, just thinking about a couple jobs you might have in the future, or maybe a product that you're developing, which might need a little bit more advanced CAM or tighter tolerance. You don't have to go and look for those high-tier CAM softwares where you can just extend what you already have within Fusion 360. So I want to make sure I brought that the information to you guys so that you know. Okay, so I'd like to talk a little bit more about why you would choose Fusion 360. What's in it? What's it about? We talk about the user interface, how easy it is, and all of those peripheral tools like training, like free post processors, and all those connected components. I could show you a bunch of slides, but I'd like to get into the interface, but I just want to kind of give you an overview of what the interface looks like. I think just touring the product will really show it off and highlight some of those aspects. So when you start off, you have a very powerful design workspace, right? So Fusion is it's a fusion of a lot of different technologies. So in design, we fuse together the parametric design, the direct editing capability, the mesh modeling, sheet metal, right, with bend components. Not that you have to use all those tools. And again, if you're just getting into machining, you might want to use some of those tools to make the part more makeable, or even make some jaws that are more accurate to what you're doing on the machine. The closer you can mimic in your design, the more accurate your program is going to be at the machine as well. But just to give you a little bit more info of what Fusion is, so we have a design workspace where we have all those design tools. We have a generative design workspace, newly added capability where you can upload your design requirements. So if you're looking for ideas or want to iterate, let's say a custom fixture for multi-axis work holding, and you're thinking of a way to hold the part, but you might have some interference or some way that a standard fixture might not work. Well, you can upload your design idea, your requirements, how you want to make it, the material you'd like to make it out of, the material you want to make it out of, and perhaps the process, whether it's going to be a cast part, 3D printed, or a hybrid of all that with machining. You can upload that information into the cloud, and AI will iterate multiple design ideas for you that you can bring back into your assembly and align your part. So it opens up some doors and opens up the imagination to some capability that you may not have today. So that's generative design. Rendering, so you can get a photorealistic of the part. If you're a mechanical designer or a mechanical engineer and you want to be able to show and get approvals, maybe have somebody take a look at the parts you're designing before you go to make them, you can actually get a photorealistic view of the part that they can look at and move around and get photos of as well. For animation, you can do a step-by-step assembly animation. We have some customers that use this as a supplement to their setup sheet. So you can place a component virtually. You could place the component right into the jaws, have a stop, and you can use it to show a new operator or even do a setup that'll walk through those steps to be able to apply that part, right? So you can save it as a supplement to your setup sheet. Simulation, this is our FEA. This is actually NASTRAN that's running in the background. Again, as we're fusing those pieces together, this opens up simulation where you can do some stress strain analysis, modal frequencies. You can even use this to take a look at the tool, like tool deflection, or even see forces on your tool. And it's outside of CAM, but at least it gives you some insight on where you'll see most forces, and you can probably even change your tool length offsets and such according to simulation. So for manufacture, this is where you're going to find all those 2D, 3D, multi-axis, turning, nesting, and all those different toolpaths that are integrated directly in Fusion. And of course, we can get all those, the designs, the drawings that you would need for inspection, your tabulated drawings, assembly drawings you can get in the drawing workspace. So we're combining all those workspaces that make up what Fusion 360 is. So I want to jump in and drive the product a little bit. And if you guys have questions, please feel free and ask. I know Jason is keeping an eye on those questions. It looks like there aren't any popping up at the moment. So I'm going to jump in and continue and give you guys more insight in the tool itself. So I'd like to kind of give you a workflow of importing a part and working with that part and setting up some toolpaths and showing what that ease of use looks like. So within our design workspace, if I wanted to, I could just start to create a design, just draw a sketch on a plane and start to extrude it or revolve it or make sweeps and such, and you can make some parametric design here. Our direct editing engine, I'm going to show you a little bit more about this soon, but the capabilities of being able to do surface modeling, mesh modeling, sheet metal modeling to make those bent brackets and such, you can easily do, just simply switch from those different tabs. So I want to import a part into Fusion 360 to work with. So up on the upper left corner is our data panel. And in the data panel, you'll see some basic projects when you first start out. You'll see like an admin project or a demo project and my first project. I'm going to create a project for today's webinar, and we're going to upload a part into it, right? So it looks like I have one here called 7, today's webinar. I'm going to make a new one. Just simply click New Project. I'm going to call this one 8. And this will be also today's webinar. So you can, again, make projects that are based upon like your products that you're making if you're prototyping. You can also make products or projects that are based upon those different customer files. So you can have a project for customer, and you can go drill into those different projects and create sub-projects. So if I want to make a sub-project, I just simply say New Folder, and I can create a sub-project, right? So I'm just going to call this one New Part. And you can have as many sub-projects as you'd like. And if you're working with a team and you want to be able to share that information, you want to work together, you could choose the People tab and start entering the email address. Now, as long as the members of your team have an Autodesk account and they have access to Fusion 360, you can add them into your project and you guys can work and collaborate together on those different projects. So in here, it's just me, but I'm going to upload a part to this new part. So I'm just going to simply click Upload. Now, there's ways that you can do this as more as a direct open, but I'm going to select the files. Now, out of these different files, I can select from my windows. So let's say I've received the file from a customer in my email, and I downloaded, I just simply put it on my desktop. So, or my documents folder. So I can go into that documents folder, and I can see I have already have some files here. Now, we do have the capability, as I'd mentioned, we have well over 50 different file translators or different file types that we can bring in. So we can bring in most of your standard, like your step files, your IGES files, SolidWorks, Solid Edge, Rhino, Pro-E, CATIA, and of course, Autodesk type files as well, like Inventor and AutoCAD. So if I want to bring in this file, I'm just going to open up this step file right here. I just simply select it, upload. It takes about maybe 10 to 15 seconds to translate that file into geometry that Fusion 360 can work directly with. So it's going directly in my project. There's also the capability of just simply clicking open, and you can open up and translate. I prefer putting it into my project because I might want to make some changes and go back to it later. So I like to define, and it's a good way to organize your projects and your files by putting it directly into that folder that's associated with that customer or that project. So it's done. So I'm just going to simply open it up, just double click, and it opens up that design within Fusion 360. So now that I have this design, it's basically this dog bone part. This came in from a step model, but again, I can bring in different types of models. We can do some direct editing right to the model. So I have this body here. And again, you don't have to be a mechanical engineer or designer. It's awesome that I've seen some pretty amazing designs out there from mechanical engineers and such. But again, if you're working in the shop and perhaps you don't do a whole bunch of design work, you don't really have to. You don't have to focus on that. But if you want to make some quick changes, maybe even put like a chamfer on the end, things like this, you could do that really quickly and easily and just start pulling different features right on the model. If you want to delete some components or different features, I could select this feature here. I'm going to hold this and just simply hit delete and it's gone. So there's ways that you can do some direct editing on the model. Again, if you want to make some soft jaws and then have it removed, do a Boolean remove as we call it, combine, you could do that really easily and make those jaws match exactly what you have going on the model. So I'm going to come back. We're going to spend a little bit more time making some changes in here, but I want to be able to show you that CAM workflow or the integration between CAD and CAM. I'm going to start to select and create or capture design history. So this is a good important part if you want to be able to capture those changes going forward. So if I capture design history, now I go to change it, I can always see a timeline in the corner here. So I'm going to switch over. Let's get some toolpaths on here, and I want to show you that CAM workflow, that integration and ease of use. So I'm going to switch from our design workspace down to manufacture. Now, by doing that, switched our ribbon bar over. Now we have all those 2D toolpaths to work with, and 2D toolpaths are driven by 2D geometry, like lines, splines, arcs, and points. So you might want to give some thought of the type of geometry that you're making. Again, you can drive this from 2D geometry as well, like sketches and so forth. 3D toolpaths are available for you, and 3D toolpaths are looking at the surfaces, faces, and edges of the model itself, which is going to drive that toolpath, looking the distance or the difference between what is stock and body. As I hover over, you see that in context help. So if I hover over like the adaptive clearing, and I want to know a little bit more about that, at the bottom of that in context window, you can see it says press Control and /. So I'm going to hold Control and /. It opens up and it gives me this solid tab. Let me go back in. I'm going to close it real quick because I'm going to highlight. There we go. So now if I hit Control /, it's now going to give me some information about that particular operation. So if I want to learn more about adaptive clearing, I have a step-by-step instruction guide that pops right up in the canvas of Fusion 360. So you'll always have help right there when you need it, right on the side of Fusion. You can turn this on, turn it off, and each different aspect, you can always hit Control /, and get right to that learning panel. So as you go through and want to learn more about setting up, that's exactly the workflow, right? So I'm going to go from left to right. Again, I just want to let you know we do have the 2D toolpaths, some 3D surfacing toolpaths, drilling, and wherever you see these little plugs, this is extension. This is where you can extend your capability. We have a robust drill workflow where you can set up all your drills for your holes, but you can add and turn on the capability coming from Feature Cam, which will now add, it's running directly inside of Fusion 360, which will add an automated tool that'll select all the drills, like the pre-drills, the spot drills, the taps. If you have all those holes in your part, it's going to grab all those tools from your tool library. So you have ways you can automate that process as well. So multi-axis toolpaths, we can do turning, as I'd mentioned. We have 2-axis turning. So if you're doing any mill turn work, it's just a matter of doing all your 2-axis work and just switching over from turning to milling, and you can drive your live tooling, your C-axis and your Y-axis tools by just simply selecting a 2D or 3D toolpath. Additive, just to let you know, we do have a full 3D printer slicer working inside of Fusion 360. So if you're doing additive as a prototype, you can absolutely set up your part and do an additive for a 3D printed part. We have most of those drivers for machines out there today. Inspection, as I'd mentioned, you can find the WCS off your part if you have a probe on your machine. And with the extension, you can turn on the capability of using your CNC machine like you would a CMM. You can check for surfacing. You could check geometry to make sure it's within tolerance, and use that probe on your machine to create your inspection report. Before you even take the part off the machine, you can make changes if you have to. If you find it's under tolerance, instead of trying to reset it up, and be prone to human error, you could use your probe to drive a lot of that inspection. And again, that's part of our extension as well. And fabrication. So we can run CNC plasma machines or laser or router and different cutters that you can run, even water jets on the fabrication. And with an extension, you can turn the capability for nesting. So if you make high production parts, if you fill up like sheets on your router, or your water jet machine, you can absolutely do nesting. So instead of hand nesting those components, within seconds you can get all your parts of your assembly nested using our nesting extension. So with that, I want to set this up. I want to go through that workflow. I just want to show you what was in the product. So the first thing I want to do is set this up. So I'm going to choose setup, select setup, and it recognizes the boundary of our part. Now we can choose, so right now, by recognizing the minimum size stock, that's the smallest piece we would need to be able to cut this part out. Now we can modify that. We can get into to make some changes. So let's say we want to put our origin in one of these corners, right? I just simply select one of these box corners or the center. So now I could just choose where I want that origin. If I want the upper left corner associated with a fixed jaw or whatever. Now, what makes it easy is if you want to flip this part over, all you have to do is select the shaft of the Z, select the face you want it to be normal to, and it flips it over. So you don't have to worry about tooling planes, machining planes, and geometry planes, and all of that. You just simply select it right off the model. If I want to choose this and select this edge right there, you can see it's now going to select that edge as well. Now I'm going to exit out. I'm going to keep that in that corner. If you wanted to, you can even select a point on your model. If I want to select, let's say, the center of this hole, that becomes our origin. So you can select other geometry, not just the stock box. So with that, I also want to point something out too, right? So we're doing our setup. I'm going to get our stock the size we want our stock to be really quickly. But while I'm here, I just want to point this out to you. Notice that on the bottom of this box, and you're going to find this with all the different toolpaths you work with, there's this little eye on the corner here. And this will give you more information about what it is. So if you need some help with setup, just simply click that eye. It brings you to our product documentation. It's basically the manual right there and ready when you need it. So whatever feature you're selecting on, you'll see that it's going to open up to the interface that'll give you a good step-by-step guide and an overview of what each of those different aspects of the software are. And you can see you can get into product documentation about design information, our extensions, manufacturing, setting up different tool paths like 2D milling, 3D milling, and there's a plethora of information available right in our product documentation. We're going to come back here, but I just want to show you that it's a really quick way to get to there right from the toolpath you're working with. So inside of here, I can get some more information to say, all right, how do I set up my stock? Just simply go into the stock tab. You could choose whether it's a relative size box, which means it recognizes the boundary around the part. I could choose a fixed size box, so I could just start plugging in the actual size and dimensions of the stock. You also have an option where you could choose from solid. So if you have a near net shape, you could just simply select that near net shape. So in this case, I'm just going to use my relative size box. We'll add some material around it. And notice as I start to type in, the box grows around my part. You can actually see graphically and with graphic confirmation what the stock is going to look like before you even start to add toolpaths. So now I have some stock around my part, my relative size of my stock box, and that's it. Right? Just simply select your part, select your boundary and your orientation, and now you're ready to go. So the next step is I want to apply a toolpath in here. Now I'm going to use a 3D toolpath, right? So I'm going to jump into a 3D adaptive clearing. So this is our roughing strategy. We call this our high efficiency roughing because we keep the tool engaged in the material throughout the cut. It recognizes when you're working with 3D toolpaths, it recognizes the boundary of the part. It also recognizes the geometry that we're trying to cut. So I'm going to select adaptive clearing. And again, you have that in context help. So this is our workflow for CAD, working from left to right. You select the tool for the job. We select our geometry that we want to cut. The heights, which are color coordinated, you can just simply grab a hold of those different heights and move them. You can also add in a number, right? So if I want this to be a ½ inch above the retract height, you can set up your heights, and it's all absolute from the top of the stock. And again, you can set that if you want it top of the body as well. Our passes, which gives you that information. And again, when I hover over each of these different fields, I get that in context help. So I have more information based on all those different settings. And again, if I want to learn more about these, I could just click that little eye on the bottom. It'll bring up that help just when I need it. So I'm not going to make too many changes in here. I will select the tool though. That's our passes where we can set up how the tool's engaged in the cut. Our linking parameters, how we lead in, lead out of the part. But first I want to select the tool for the job. Just simply go into select, brings up our easy to use tool library. You can create your own tool library. Just right click, add new tool library. And you just simply add your library and start populating tools to it. Now, there's also the capability of using some standard tools. So I have some sample tools that we can choose from. And in those sample tools, so you don't have to start from scratch. If you do have tool libraries, you can import them. There are ways that you could just simply import your tool library directly into Fusion 360. Now, the sample tools we can filter down. Right now, it knows we're doing some milling because the toolpath we selected. And if I want to choose, and maybe I want to do a flat end mill, I just simply choose flat end mill and I can select from different tools. So if I grab this 1/4 inch tool, it already has some speeds and feeds set up according to that material. So we're going to rough some aluminum. I just simply select that tool. I can see it in the graphics view. Now, since I'm doing a 3D adaptive, I don't have to select any geometry. It recognizes right on the part and it knows the difference between stock and body. I just simply say, okay, excuse me, and it starts to apply that adaptive clearing toolpath to rough out this part. Now I could see it gives me this kind of preview. I could change the way I preview it as well. It looks like there's a lot of linking moves in there. I can always go back and change linking and get that tool to stay down a lot more. But it looks like it looks pretty good. I roughed it out. I want to see what it's going to look like. I'm just going to go up to simulate. So if we go to simulate, you can simulate right on the part. You don't have to leave this environment. It's actually going to look directly at the part itself, and it's going to simulate within the part. And it looks like I'm kind of getting a preview here. It looks like we might even have some collisions in here. When I selected my tool, I never selected the tool height. So it's going to try to put that tool where it can. I'm going to choose over here. Actually, it's already chosen to stop on collision. So I'm going to let that run, and I can see exactly how the tool is going to approach. But if there's any place where that tool may collide, or the tool holder may collide with the stock, or if I even choose a fixture, I want that to stop exactly when it's going to collide. So I can see it highlights in red, shows me exactly where it collides. That holder is going to collide with the stock. So you have that built-in capability where it recognizes any place where you might run into trouble when you post out your code to your machine. So now I know I probably want to go back and update my tool height just to avoid those crashes, but I can see, at least I can see it in my simulation that it caught it for me. Right. So sometimes I can be prone to accidents like that. Sometimes I might put the decimal point in the wrong place, not even think about it until I simulate, and then whoa, I don't want to crash the machine. So now I want to go back, and I can easily go back into the tool library, make a quick change here, edit my tool, just right click, and it has this easy to use wizard here. Going from left to right, I'm going to change the cutter. We're going to change our overall length. We'll make our cutter length, let's say 1.5 inches. We'll make our shoulder length also, we'll do this at 1.25 inches. And we're kind of plugging in, we'll also make that 1.25 inches. So just plug in the aspects of the tool that you have, what's really in your tool holder. So I accept that change. I can see the tool's longer now. And now, oh yeah, I'm going to change my optimal load. I'm going to reset the system default. You can always right click on any of these fields and set any of your defaults. So as you're setting up your toolpath and you're dialing in of course, your feeds and speeds, but you're dialing in what the offset would look like, your step down and all that information, you can easily plug them in here. So I want this to go 3/4 of an inch. Actually, I want this to be 0.75. And so you can dial in and plug in your defaults and you could save them. So this way you don't have to rewrite the wheel every time you do a toolpath. We have the capability where you can plug in your standard defaults. And also, and maybe not in this webinar, but we can talk about toolpath templates. So now you can set up a series of toolpaths and save those out as a template that you can reapply to any part going forward. So I'm going to set that as my default, say OK, it reruns my tool or reruns the toolpath, and now I won't have any collisions because I have a long enough flute length and long enough tool. So that I got to the part, I can see it looks pretty good. I might come back later on and finish this one up, but we just want to get some code out to the machine, right? So I just want to rough it. So from here, I have that adaptive clearing. I'm just going to choose up here. Now, before I go to output, the code to the machine, I want to create a setup sheet. So inside of here, I can create a setup sheet that'll show the operator, show myself, so I can remember which tools I'm using, what the toolpath looks like, where our WCS would be, touching off on the corner of the part. We can see which tools we're using, the maximum feed rate, maximum spindle speed, and the estimated cycle time it's going to take for the operation. How to set up the tool in the holder, and as well as each operation, it's going to now show us all the information we need for that operation, including the cycle time as well. So it's a really good setup sheet right out of the box. So now I can see how to set up the tools. We want to post process. So now I can output the code for my particular machine. So going through and just simply going through this as a wizard, I want to select the post. Now, we do offer, I believe we're almost up to, or actually we're surpassing 200 different machine controls that we can support in our tool library. They're not encrypted. They're all free. They all come with Fusion 360. We have a robust library, and you could select different posts from that library. So if I'm running my Haas next gen control, I could select it. We do have the next gen control post, as well as the post for like the UMC 750. We do have a lot of the Haas post, as well as FANUC and most of your machines that you'll find out there. But I just simply select the post, select where I want to output it to. If I want to put it right on my thumb drive to bring right over to the control, I could select it right here. I want to see the posted program. I have some settings that I can set in here, specifically if I want to do like smoothing and look ahead, I can do that as well. So I'm going to post out the code. Looks like I did this earlier. I'm just going to overwrite that code. Now I have that G code that I can send right over to the machine. Now, one thing I'd like to point out, and that's within a couple minutes, we're able to just put a cool toolpath, an adaptive clearing on there. Now the question comes up now, if the customer has a change, we need to change it, or maybe even change the soft jar or whatever, we need to make a change. We could just simply jump from manufacture back to our design. There's that integrated workflow, right? You don't have to leave the environment. It's very familiar, right? And it's an integrated work that you can do. So I just simply jump back to the design, and the customer wants to take, like we remove that one hole, but they want to rotate this hole around, right? So we want it to be opposite on the other side. I'm just going to grab that geometry. I'm just going to move it. Just choose move. I could select this center point of this axis, and I can rotate that hole right around to the other side of the part. So maybe I'll go 66 degrees or something like that. There's 60 degrees. So now I was able to move that whole feature. It updated. Now I have that move feature on my timeline here. So let's say we also want to make a change to this hole. We can also do a press pull. And press pull is like your Swiss Army knife. And again, you might not have to do changes like this very often, but if you do, it's a really quick way to interact with your parts. I can grab this hole and just shrink it down. You can add a dimension in here and show how big you want that hole to be. And if you want to, you can even do things like this and grab a hold of a pocket and move it down. So really quickly, you can make some integrated changes. Now, if we go back to our manufacturer workspace, and I'm just switching from design to manufacture, you can see our toolpath is still cutting the old size and shape. All I have to do is just right click, oops, not edit, sorry, right click and generate, or you can hit Control G. It regenerates the toolpath and it recognizes the new geometry and updated our toolpath accordingly to that geometry. So in like 30 seconds, I was able to go through, make a change to the model, bring that change through, updated our toolpath, and now I can go and post out code and post process out and overwrite that program. So I know at this point, I'd like to kind of give you a little bit more of, show some of those tools that are available for you for training and learning and getting into more knowledge about Fusion 360. I'm just going to check in. I don't know if Jason has, if there's any questions that you guys might have so far, and I'm happy to jump in to help answer. But I know Jason does a really good job of covering those questions in the webinar. It looks like we don't have any at the
Wayne, we
moment.
actually do.
Oh, cool.
Yeah, so GWB wanted to know a little bit more about HSM Works in particular. So the question more specifically is the SolidWorks add-in, HSM Works, that's included with Fusion 360, is it the same CAM workflow that you would see in Fusion 360 itself?
That's a great question. It is. It is. It's actually the engine that drives HSM Works, which grew up and started as a plugin for SolidWorks. We now have it as an integration. It is the CAM for Fusion 360. All these toolpaths, the 2D toolpaths, the 3D toolpaths, the drilling and multi-axis are all exactly the same. They work the same. You can use the same post processor. You could use the same tool libraries and all the same templates. So they're exactly the same workflow. They just look a little bit differently because inside of Fusion, of course, we have them inside of our workspace for manufacture. And in SolidWorks, it uses the SolidWorks interface. It looks more and feels more like SolidWorks. But the workings behind it are exactly the same CAM. Now, one thing I'd like to add too, as we talked a little bit earlier about those extensions, the extensibility of being able to use tools like PowerMill, FeatureCam, and PartMaker directly on those toolpaths, those are only going to be in Fusion 360. You won't see any PowerMill toolpaths or advanced toolpaths inside of HSM Works. So just the base the base toolpaths you see in Fusion match the base of what's inside of HSM Works. So good question. Awesome, awesome. So as you're getting into and working with the design workspace and the CAM workspace, and you can get information on all in between, right? So all those different workspaces we talked about. One place I recommend and a place to go to learn Fusion 360, just simply go up to this question mark in the right-hand corner. And inside of here, we have access to our community, which is our forums and feedback hub. But more importantly, inside of the learning and documentation is our self-paced learning. So if we select our self-paced learning, it brings us back into our main page of Fusion 360. And this is our courseware. It's all online learning and tutorials to help get you up to speed on how to work with Fusion. So if you're just getting started and you want to learn about like the data panel and how to get and organize your files and your projects, this is a great place to start. When it comes to 3D modeling and you want to work with sketches and learn how to make some of those models, and whether it's parametric, like our form models or sheet metal models or surface, this will walk you through step by step on how to do that, right? There's tutorials available. And this will bring you all the way down through to CAM. In fact, it's the same part we're looking at today. This will walk you through step by step on setting up, doing your setup, your orientation, all the toolpaths to be able to rough and finish this part with drills and such, and how to post code out. So this will walk you through not only for milling, but for turning. And if you're doing any multi-axis work, or if you're doing 3D surfacing toolpaths, this will be these are all free, and they're all tutorials that'll walk you through each of those processes. So as part of those resources, I highly recommend checking out more of these resources in that same workflow, where again, we looked at our product documentation, which is the manual, which walks through all the different aspects of the toolpath and gets really deep. Our self-paced learning, which we just looked at. If you need any help, we do have our custom software development. This is our resellers. If you need any help with post processors or specific training, you can reach out and contact any of our partners out there who can help you and get up to speed, right? So you have access there. Events and webinars. I highly recommend checking out when we have upcoming webinars. I know Jason does a lot of our webinars for design and even some for CAM as well. And you can see what's up and coming. Here's today's webinars that we're doing today and ones that are up and coming in the future. And you'll see a lot more webinars added in here to help learn and help you grow within Fusion. So I recommend going into this page. We have our blog. This is where you can see what's new and what's up and coming, and new features that are coming in Fusion 360 are also in this blog as well. And also, I highly recommend visiting our YouTube channel. Right, there's a lot more information. There's very specific webinars. This webinar is going to be posted in our YouTube channel. This is your Fusion 360 YouTube. So if you want to search in YouTube for Fusion 360, you'll see that we have our tutorials. These are really worthwhile of taking some time. Machining setup. We have advanced users in here who are making a lot of these tutorials and webinars. There's Jason. And Jason will walk you through some designing and 3D printing. There's Angelo and Brad. They're all experts, and they do a great job of teaching you and going through and answering questions right on those webinars. So, and these are 360 live views. So I highly recommend jumping into our YouTube channel, learning, using these to get up to speed. They're always there and available for you. Also, there's other aspects that you can jump into as well, getting started those tutorials and asking questions directly within our forums. So if you jump into the forum, there are experts in here every day who can answer those questions. We have our elite users. Sometimes you might even see members of our service team as well. But you can see it's a very robust and active forum. So people are just getting answers just minutes ago. So I would highly recommend if you have questions about your post, or if you have questions about, setting up toolpaths, or if you're finding, if you're hitting some roadblocks and you're spending 20 minutes spinning your wheels trying to get it to work, I highly recommend jumping into this Fusion support. This is for manufacturing, but you could find the community for design as well and our API. But I highly recommend using our forums. There's a lot of knowledge out there for you. You can also reach that same forum up in the question mark, as I had mentioned. We have this community. This will get you right to our forums list, our feedback hub, our roadmap, and then especially check out what's new. Fusion 360 is updated regularly every 6 weeks, but when there's like fixes and things and what's coming in the software and even some announcements of what's happening, the what's new is a great place to learn and understand what's happening with Fusion. So, and it looks like I know. Awesome. So Jason's been answering some questions. I see he's been posting some links for you guys. Absolutely, yeah. I would highly recommend visiting some of those links and those videos that Jason's recommending right now. Awesome, awesome. So yeah, I wanted to make sure that we were able to reach those different aspects of the software. Let me jump back into my presentation really quick. So the last part, as we talked about, we were able to show you where you could, or why choose Fusion 360, all of those tools, including the post processors, our capabilities, which are expanding and such. Lastly, how can you get in touch with us? So we have offices all around, pretty much around the globe, that you guys can reach us to ask questions, find out more about Fusion 360 and our extensions as well. If you want to start a subscription and you want to learn how to access it that way, please feel free, send an email, reach out to our team. We're here to help and get you guys up to speed. I know Jason was pasting some of these links, and I know he'll paste them into our chat as well. Yeah. So I want to make sure that you guys have a clear access where you could find us and send emails and get in touch. So just to sum up, we will have a couple seconds here for a Q&A. But I just want to cover and make sure that or summarize and show what we talked about today. about myself, about Autodesk. Why would you consider a CAM software? Think about some of those aspects, right? So you have models that you want to upload or design. Does it have integration with CAM? Is it an easy workflow? Do you have access to post-processors? Because one of the other important parts, not only having a good CAM model, is making sure you can get good code to your machine. So take all those aspects in consideration if you're trying to get a fast, efficient, consistent, and affordable workflow for CAM. And hopefully we're able to cover a lot of that here and get you guys up to cutting chips really quick. So with that, I just want to check in with Jason to see if we have any questions, and we're happy to take the last 5 minutes we have left and answer those questions for you guys.
Wayne, it looks like all the questions that were asked were either super technical questions that would kind of change the course of your webinar entirely, or some technical issues I was able to hopefully solve. So that's it for questions.
Awesome, awesome. And we were capturing those questions as Jason had mentioned, and we can definitely get back to you following the webinar. So if you have some really good questions, we're happy to point you in the right direction and we can answer them directly. So awesome. Yeah, I appreciate everyone coming to our webinar and learning a lot more about how to get those chips flying on your machine a lot quicker. And so yeah, and keep an eye out for future webinars. You'll see Jason on them. You'll see our team doing some of these webinars to get you guys more up to speed on how to work with Fusion. So thanks again, everyone. And we'll see you next time.